This is the circuit. This is Vs in series with Rs. This is the independent source with the resistance Rs. This Rs is internal resistance of the source, internal resistance of the battery. Internal resistance of the battery. Internal resistance of the battery. Load we will connect here. This is RL. When the power will be maximum. Power will be maximum means when the efficiency will be maximum, like that we can take. When the power delivered will be maximum, because delivering power should be maximum to the load. That is efficiency, high efficiency. When the efficiency will be higher, if Rs equal to RL. Rs equal to RL. Then power will be maximum. Power will be maximum. So what is the expression for load power? That is equal to I square RL. Am I correct? Current through, let the current through, this is I square RL. That is the power across load. PL equal to I square RL. Or we can write in terms of, if you want to write in terms of source and resistances, I can be written as Vs divided by Rs plus RL. Am I correct or not? I can be written as Vs upon Rs plus RL whole squared multiplied by RL. Here, if you want, this can be written as Vs square upon RL divided by Rs plus RL. Can I write like that? Sorry. This can be written, right? Okay. Whole square RL. Can we write like that? RL upon Rs plus RL whole square. This power, when the power will be maximum across the load is the question. So in mathematics, what we will do? We will differentiate that with respect to RL and equate to 0. Do that. We have to differentiate this with respect to RL. Therefore, we have to find dPL by dRL. So if you differentiate with respect to RL, what you will get? What is in the denominator? Vs square is constant. Let it be as such. Here we have to write Rs plus RL. Already square is there. If you square that, it will become 4. So we have to write this as such. What is that? Rs plus RL whole square. We have to write as such in the denominator. Differentiate the numerator, you will get 1. Minus, write the numerator as such, differentiate the denominator. What you will get? 2 times Rs plus RL. Am I correct or not? 2 times Rs plus RL. If you differentiate again Rs plus RL, you will get 1. That also we have to write. That we are not writing. So, equate this to 0. Equate this to 0. We know that Vs square is not equal to 0. It is not equal to 0. We know. Vs square is source is 0 means how maximum power will be delivered. That's why Vs is not equal to 0. That's why the remaining part is equal to 0. So we can write Rs plus RL whole square minus RL 2RL multiplied by Rs plus RL upon Rs plus RL whole square equal to 0 means the numerator must be 0. Otherwise, the denominator must be infinity. It is not infinity. Rs plus RL is not equal to infinity. We know. That's why numerator must be 0. So we can write Rs plus RL whole square equal to 2RL multiplied by Rs plus RL. This and this getting cancelled. Therefore, what you are getting? RL equal to what? RS plus RL. RS plus RL equal to 2RL. It means what? One RL getting cancelled. This and this getting RS equal to RL. RS equal to RL. If source impedance equal to internal impedance or source impedance equal to load resistance, load impedance, then the power will be maximum. The power will be maximum. This you can imagine the other way. If in mechanical, I do not know whether you studied or not, I'll tell anyhow. If constant losses equal to variable losses, then efficiency will be maximum. Have you studied anywhere? Here also the same meaning. We cannot change RS. We cannot change RS. Therefore, whatever may be the power, for a particular road, power loss across RS is constant. Am I correct or not? We cannot change RS. RL can be, depends upon our requirement. But RS we cannot change. That's why we can say that RS is constant loss. Power loss across RS is constant loss. But power loss across RL variable. That is up to us. The value of RL is up to us. Therefore, constant loss equal to variable loss. Loss across, what is current through RS? Same I. Current through RL also same. So I can write constant loss equal to I square RS equal to variable loss equal to I square RL. These two getting cancelled. Therefore, RS equal to RL. Constant loss equal to variable loss. That is mechanical meaning. So wherever you find the constant loss equal to variable loss, then efficiency will be maximum. That concept here in other way. That is maximum power transfer theorem. Suppose I am having a circuit like this. I am having a circuit like this. What is maximum power? What is the maximum power in a circuit? In this circuit, what is the maximum power? RS equal to RL. Therefore, what is the formula for power? Vs upon RS plus RL whole square multiplied by RL. Put RS, RL, wherever you find RL, you put RS. What you will get? Vs upon 2RS whole square multiplied by RS. Or Vs square upon 4RS is the maximum power in any circuit, where RS is the internal impedance of the circuit. Internal impedance of the circuit. For example, I am having a circuit like this. I have copied. When maximum power will be transferred, instead of asking a statement, they may ask like this: when the maximum power will be transferred. Internal impedance equal to load impedance. Internal resistance equal to load resistance. Impedance means different meaning. That also I will tell now. Internal impedance equal to complex conjugate of load impedance equal to complex conjugate of internal impedance. For example, if it is a AC circuit, ZL equal to ZS star. Star means what? Complex conjugate. For example, ZL equal to ZS equal to 4 plus J3. Let us assume. Therefore, ZL must be 4 minus J3. 4 minus J3. Then the power will be maximum. This is for AC circuit. For DC, real part must be equal. In both cases, real part must be equal. Whether it is AC circuit or DC circuit, real part must be equal. But complex part must be complex conjugate. In internal impedance is plus J3 means load impedance must be minus J3. Minus J3. Then power will be maximum. This is for AC. ZL equal to ZS star. We cannot change ZS. That's why ZL must be equal to ZS star. Why don't we write ZS equal to ZL star? This is wrong. Why? We cannot change ZS. We can fix ZL only. ZS is fixed. That's why this is also mathematically correct. Mathematically correct, but physically not possible. That's why ZL equal to ZS star. This is also answer correct. But you should not tell like that. As an engineer, you should not tell like that. We should check whether it is physically realizable. So ZL equal to ZS star. The complex conjugate of internal impedance must be load, then the power will be maximum. So now we will first check for DC circuit.